Okay, so let's finish up our modeling of exponential equations, and then we're going to get into properties of logs, and then that will be it for this unit. Okay, so yesterday we talked about these three equations here. When interest is accrued once a year, we use the one that we've already been using, right? Also with the problem that's decaying, we would use this problem here. When interest is accrued more than once a year, then we have to actually divide it by how many times in a year. So semi-annually would be divided by 2. Yes. Accrued. Accumulated. And then you'd have to also make sure that if you're dividing it by 2, you're also taking it to the second power as well, because we're going to do it twice. Make sense? So let's say I said monthly. I would divide it into 12 pieces, and then we would have to take it to the 12th power as well. Okay? Then, when I hear continuously, that's when we use E. All right, so let's use it. We started here yesterday, and we said, use a graph to find the number of years it will take for the value of the baseball to get $20. And we said that now that we have logarithms, we can solve exponents. So the first thing I would do with this is I would divide both sides by 3. Then I would be left with 20 over 3. It's not necessary to put this into a decimal. Just leave it like that in a fraction. It'll make your answer more accurate when you put it into a calculator. Is 1.1 to the t. How do I get rid of the t? I'm going to use logarithms, because logarithms allows me to bring that t out front using the power to a power property. So now I'm left with log 20 equals t times log 1.1. And finally, I just divide both sides by log 1.1. And when we put that in a calculator, if I remember correctly, we got 19.9, which we said was reasonable, because if we look at our graph, and I look at after $20, that will take about, that would take about 20 years. Okay, so I'm going to do one of each of those types of problems, and then we're going to get going. And you guys are going to work on your own. Okay, skip over that one. Okay, Johanna invests $2,500. So that's my initial investment, $2,500, in an account that earns 5.2% annual interest. You got to be careful with these, right? We learned in the very beginning, you've got to be able to turn that into a decimal. So I'm just going to talk like it's in percents to begin with. So I have 100%, and I'm adding 5.2% for t years. How long will it take the account to double? So doubling means going to 5,000. Start with 2,500. How long is it going to take to get to 5,000? So I'm going to divide both sides by 2,500. And at the same time, I'm going to fix this problem right here. This is really, let's change the color of that to a red. This is really 105.2%. If I want to change that into a decimal, I'm going to have to move over 2 decimal places, so it's really 1.052. Okay, so this is going to be 2 equals 1.052 to the t. Now I'm ready to log both sides. So log this side, change my color, log this side, and log that side, and we're left with log 2 equals t times log 1.052. Now just divide both sides by log 1.052. And now we just really need to practice putting that in our calculator. So what is log 2 divided by 1.052? Put it in your calculator. Log 2 divided by log 1.052. 13.67. We're talking time, right? How long is it going to take? So I would get 13.7 years. It would take 13.7 years to double our investment. That's a long time. Yes, Jonathan? Okay, ready for another one? I've got 2 more to do. This one is a little different because it talks about compounding semi-annually. I did this one yesterday. Would you like me to do a different one? You want me to do it again? Okay, I didn't finish it, so. All right. So this one says Doug invests $2,000. Here's his initial investment in an account that earns 8% annual interest. So that's 100% plus 8%. Compounded semi-annually. That means I need to take this and I need to cut it in half. Semi-annually is twice a year. And when I cut it in half, I'm going to have to take it to the second power as well. Semi-annually means twice a year. So that 8% needs to be cut in half because it's going to happen twice a year. Okay? How long will it take for the account to reach 10,000? So I'm going to divide both sides by 2,000, which gives me 5,000. Sorry, not 5,000, 5. 10 divided by 2 is 5. And now I'm going to take care of this. This looks messy. It's really not. What's 8% cut in half? 4%. So I really have 104%. 104%. 104% is really 1.04. So I have 1.04 to the 2t. You have to change it into that decimal before you put it in your calculator. Your calculator's not going to understand the percent. Jonathan? Because 2,000 divided by 10,000 divided by 2,000 is 5. I divided both sides by 2,000. Thank you. I shouldn't have skipped that step. Okay? We good now? So now I'm going to log both sides. Log. Log. Left with log 5 equals 2t times log 1.04. Divide both sides by, couldn't I divide both sides by 2 log 1.74? Why not? Right? Let's just do it this way. If you guys don't see it, I don't want to mess you up. So this goes away. And we're left with, oh look, there's the answer. I didn't erase it all the way. I'm writing smaller, this one. Okay, so now I have log 5 over log 1.04 equals 2t. Now I need to divide this, put in my calculator, and divide by 2. So finally, I have log 5 divided by log 1.04, and I'm going to divide that answer by 2 to get t, and you should get 20.5. How are we doing? One more?
Yeah.
I think these are the best ones to do because, like the day before, what you guys did yesterday, that worksheet, all you were doing was manipulating the logs, right? But this one you actually have to build the equation and then manipulate the logs. All right, last one. This one is really, really long, but it's not really that bad. I'll set it up. Stringed instruments like guitars and pianos create a note when a string vibrates back and forth. What key things am I looking for?
The percent.
The rate?
Yeah, the rate.
What we're going to start with? And what we're going to end with. Right? Okay. The distance that the middle of the string moves from the center is called the amplitude. And for a guitar, it starts, right? There's my key word. It starts at 0.75. It's my initial amount. When a note is first struck, amplitude decays, means I'm going to use a minus sign, right? Amplitude decays at a rate that depends on the individual instrument and the note. But a decay rate of about 25% per second is typical. 100% minus 25% to the t. Now I just need what we're going to get to. It's going to decay, so it's going to be a smaller number than this. Calculate the time it takes for the amplitude of 0.75 millimeters to reach 0.1 millimeters. So that's set up. Now I'm going to go find one with continuous. There it is. Going to use E. The grandparents of a child born in 2016 deposit $5,000 into a fund that earns 100% plus 4.5% interest continuously. As soon as I see the word continuously, I'm going to change this portion right here to E. Actually, let me back up on that. This portion right here is going to change to E. Let me show you. So it's going to be 5,000 E. Now my rate is going to be a power, or an exponent. So 4.5%, remember, be careful with that. 4.5% is really 0.045. The t equals 9,000. How long is it going to take to reach 9,000 if we compound continuously? What do you guys think?
You have to divide by 5,000.
Totally, but how much time do you think it's going to take? I think it's going to take not very much time, because when you compound continuously, right, it rises fast. That's what it means to happen continuously. It's like getting interest by the second. Can you imagine? You're like, oh, I just got interest again and again and again and again and again and again, right? Okay, so let's solve for it. So I'm going to divide both sides by 5,000. No need to simplify here except for, I'm going to leave it, I'm just going to get rid of the zeros. So I have 9/5 is equal to E to the 0.045 t. Now what do I need? ln both sides. Remember, this is ln e. Whenever you get to use e, like, it cuts half of your calculations down, because ln to the e just cancels. It's just 1. So I'm left with, do you see what I mean? Why that makes your life so much easier when you get to use e? So now I have ln 9/5 equals 0.045 to the t, and now I just divide. 0. You guys put that in the calculator for me. What do you get? What? 13.1? That seems high to me. $13.1. It is, yeah, you're right. It is only 4%, but it doesn't seem right that to get to $9,000, it's going to take 13 years. Maybe. Still doesn't seem. I guess because 4% is really, really low, right? That's a little tiny amount. All right, I think we're ready. I'm going to go ahead and pause it, the recording. We're going to work on our problems for a little bit, and then we'll get started on the last lesson. Okay, let's look at the last thing we're going to look at for this unit. What is a logarithm? It's an exponent. And when do we use logarithms? You should be able to answer that now. Okay, Amadeus says we use it when we need to find how long a certain point. So basically when we're solving exponents. When we need to find an exponent, we use logarithms. Okay, so we've already talked about the powers. We got 3 properties that we use to manipulate logarithms. We've already learned power to the power property. Okay, in exponents, power to a power property means b to the n times n, right? It's n times. How many times? So we've already learned that when we use logarithms, it's like pulling the exponent out in front, because if logs are exponents, I want to know how many times my exponent's happening. So that's why this is saying how many times my exponent is happening. So you guys kind of see the relationship between those two? I don't know why it did that. That's really, really weird. So that's our power to a power property. We've already been using it. Here's a new one. Does anybody remember what the product property does? The power property is the multiply. The product property is adding. We should change the name? Okay, so what do you think that's going to do with logs? It makes it so that I can split the m and the n up and adding. So if I'm saying the log of 2 different exponents, the product of them, it's just like saying splitting them up. This is kind of in reverse, right? It's like splitting them up. Do you kind of see the relationship between the two? They're exponent rules, but we're applying them to logarithms. So what do you think this one's going to look like? Okay, why is it minus? Let's talk about that for a second. So if I had 2 to the 4th and 2 squared, aren't I going to subtract 2 of them? Make sense? So that's why we use that subtraction rule. I've always expanded it and just canceled because I don't like rules, but if you know the rule, it helps you with logs because what do you think that's going to look like? Log n minus log n. So what we're going to do today is we're going to actually work in reverse. So reversely, can you do those?
Oh, yeah.
The power property, what if you undid the power property? What would it look like?
B to the n, B to the n,
It would be log bx to the n, right? That's in reverse. What about this one? Log mn. And what would this one look like? Are we ready? Okay, so we're going to work in reverse. Okay? The only reason we're going to use PEMDAS or GEMDAS or GEMMA or whatever you want to look, but we're going to use those orders of operations to do this because these are going to be big, long, ugly things, and we're going to simplify them down as much as we can. Okay. So the first thing we're going to do is we're going to decide which properties are appropriate. The second thing we're going to do is we're going to consider our order of operations, and then we're going to simplify as far down as we can go. All right, so I'm going to start with this one. What you're going to want to do is you're going to want to use parentheses, highlighters, whatever you need to do to make sure you can make sense of this. So what this is saying is I've got this right here. That's one is a different color. I've got one thing happening right there. I've got another thing happening right here. And I've got a third here, a third logarithm there. This I can't do anything with. This I can. This is saying this I can use the power property on. Because it has a 4 out in front of the log, I can put that 4 as an exponent. And this one has a 3 out in front of the log, so I can make the 3 an exponent. So I'm going to rewrite it. I have log 7, I think I'm just going to use black. I have log base 7, 3, plus log base 7 y to the 4th, minus log base 7x cubed. Now I'm going to work from left to right, just like you would in order of operations, right? If I had 3 plus 4 minus 5, I would add these first and then subtract the 5, correct? Okay, so I'm going to do this one first. Take care of that first. So I'm going to use the product rule for that one. So that would make this log 7, 3y to the 4th. This one and this one are products. Okay? Minus log 7x cubed. Next, I'm going to use my quotient property. So these are going to become quotients. So it's going to turn into log base 7, 3y to the 4th, divided by x cubed. This is kind of the only part of logs I don't like. Because what does that mean? It means nothing, right? The whole point of properties of logs is just to get, it's like a puzzle. When are you going to use this in life? Never. When are you going to use it in calculus? Not at all, right? The reason we're teaching it, right, originally Common Core cut it out. Because this is not a Common Core thing to do, right? All you're doing is manipulating. It will help you in calculus and math analysis to be able to, guys, it will help you later on in math to be able to manipulate equations, right? You're using properties of exponents, which is a useful thing to do and know how to do, right? But when it comes down to what happened is California added it back into the standards. It's only a California Common Core standard. I love Common Core. I don't like how California has added a bunch of standards when everybody else doesn't have those standards, just California. Okay. Okay. Why don't you guys try this one? That was the answer. So you guys try that. Yeah, we're just simplifying. So like what we did with the modeling, that's useful logarithms. We were actually finding something. You know what I mean? We were using logs to figure out how much time interest is going to accrue. So try that one. I'm going to pause it. 1. Okay, so what properties are we going to use? First of all, we've got that's a log and that's a log. We're going to start with the product property, the power property. Power property first. So now I've got log base 2 to the 10 plus log base 2 to the x cubed. And now I'm going to use the product property, and I'm going to combine 10 and x cubed. So now I have log base 2, 10x cubed, and that's all I can do. You're just simplifying. Yeah. It just goes away because we combined them. All we're doing is we're combining this and this. Another one? You want me to do it? Okay. Kinda. Alright. So I'm going to start with grouping symbols first. ln 3 minus ln x, I can use the quotient property for that. So the first thing I'm going to do is I'm going to combine these two using the quotient property. Then I'm going to combine these two also using the quotient property. So I'm going to rewrite that as 3 times ln 3 over x plus ln x over 9. This is where you have to be careful. 3 needs to be distributed to 3 and x. So I'm going to use the power to a power property, but when I do that, I have to be very careful because it goes to both of those. Just like if I had 2/3 and I cubed it, that means 2 cubed over 3 cubed. Right? Or I could distribute it from the beginning. So either way, you would have got the same answer. So now we have ln 3 cubed, we'll just do it, 3 to the x cubed, or 3 to the 3 over x to the 3. Would you like me to rewrite that step? 3 over x cubed plus ln x over 9. You know some teachers will mark you off if you don't have equal signs here? Okay, moving on. It's funny because there's some teachers that feel very strongly about it, and there's no arguing with them. They really, really feel strongly, and there's nothing wrong with that. But I just say to myself in my head, I'm like, well, I do that all the time, though. So how am I going to mark somebody off when I always forget mine? I must not have had a very strict Algebra 1 teacher. All right, so now I'm going to use it technically. Yeah, because you're saying this is equivalent, this is equivalent, this is equivalent. We're simplifying. So I'm going to use the product property to combine those two. So I'm left with ln 27 over x cubed times x over 9. And we can simplify in here. 9 and 27 make 3. X and x cubed make x squared. That's as far as we got in the other class. I'm fine with stopping there. And you guys did really good today. So we have 3 over x squared. That's our final answer. I should probably be consistent. ln. All right, so that's it for today.